Hello friends, so welcome back to my channel Sulba Sutra Academy, where and my name is Sumit Mishra. So today we are going to learn about the topic called irrational number. Of course, this is exercise 1.3 of CBSE class 10 maths book. So let's start and see. So before moving to the problems and all, let's understand first what is rational number and what is irrational number. As I have already explained you a little bit about this in number system, so let's revise it again. Okay, so let's understand what is a rational number first. So what is rational number? So a rational number is a number which can be represented as a ratio of P by Q. Okay, where P is an integer, Q is also an integer, but Q should not be equal to 0. Understand, it should not be 0. If it is 0, then it is irrational. So P should belongs to integer, Q should belongs to integer, and Q not equals to 0. If you are able to convert any number as a ratio of P by Q, then it's a rational number. Anything, if you are able to represent it in the form of a ratio P by Q, where P is integer, Q is integer, Q not equals to 0, then it's a rational number. Example is 2 by 3, then 3 by 5. If you are taking only numbers, also 5. This is also a rational number. Okay, then let's move on. What is irrational number? So irrational numbers are numbers which cannot be represented as a ratio P by Q. So irrational number cannot be represented as P by Q. As simple as that. And even if it is P by Q, then Q should be 0. The condition is Q should be 0. Then only P by Q will be a rational number. So P by Q is rational only when Q equals to 0. This is the second thing. And third thing is, so how you will identify the irrational number? So the most of the problems, it will be like if it is inside some root, and that root should not be solvable. So root 5, there is it's not solvable. Solvable in the sense, if you are writing root 4. So root 4 we are writing 2 into 2, root under of 2 into 2. So it will be 2. So this is solvable. So this is not irrational number. This is not irrational number. Root 4 is not an irrational. But root 5 is irrational number. Similarly, root 7 is an irrational number. Root 11 is an irrational number. Okay. Other than this, there are things called E and pi. Okay. These are also irrational number. Pi, even when we use it in the normal mathematics 22 by 7, but that is not its exact value. You will not able to get its exact values. So pi has been kept in the irrational number segment. Remember, pi is irrational. Even when we can write it, generally if you are doing circle and all, so we write pi r square for the formula of the area. There pi we write it as 22 by 7. So normal, if you are writing 22 by 7, then it's a rational. But pi value, even when we tell pi equals to 22 by 7, it's not the actual values. Okay, this 22 by 7 is not, it's a near about value that is given to pi. So pi is an irrational number. Okay. Now understand what is co-prime. What is co-prime? So two numbers, a pair of numbers are called co-prime if they have no common factor. Pair of numbers having no common factor. They are called co-prime. Take an example of 21 and 22. So 21, if you are doing LCM, so 3 7 7 1. So 21 has a factor of 1, 2, 3 and 7 and 21. And 22, similarly, if we are doing for 22 also, then 2, 11, 11, 1. So 22 has a factor of 1, 2, 11 and 22. So if you will see over here, they have a common factor of only 1. Other than that, there is no common factor. Correct? So HCF will be 1. HCF of this is 1. I did some mistake for 21. There is no 2 over there. There is no 2. Only 1, 3, 7 and 21 is there. Okay. And 22 it is 1, 2, 11 and 22. So if you will see over here, there is only one common factor, 1. So co-prime are the prime which have factor. I mean, no common factor in the sense it will have factor of only 1 that is common. As simple as that. And HCF should be 1. Okay. So this pair of numbers are called co-prime. Clear? So co-prime are the pair of numbers having no common factor. If you want to add, then no common factor other than 1. So only 1 should be their common factor. Then the pair of the numbers will be co-prime. Okay. Now let's start doing the exercise. So this 3 point is very important. So in exercise 1.3, generally we need to prove that a given things are irrational. That we need to prove. So let's start from there. Okay, so let's start doing the exercise. So exercise 1.3. Okay, so the first question is prove that root 5 is irrational. We know it's an irrational, but we need to prove it that root 5 is irrational. Okay, this we need to prove. Okay, so let's move on. So to prove it, we have to prove by the contradiction method. Okay, so proving can be done by the normal steps also or by the contradiction method also. Contradiction in the sense is you have assumed something and that assumption you are making it fail at the end. Okay, so let's do by the contradiction method. So assume root 5 is a rational. So let root 5 be a rational number. Rational number. So of course, since it is a rational number, so we can find two co-prime integers. We can find two co-prime integers x and y, where y not equals to 0, okay, such that root 5 equals to x by y. Clear? So we have assumed it's a rational number. So since rational number is nothing but a ratio of integer, correct? And we have assumed that integer should be co-prime. Clear? So x and y are the co-prime integer where y not equals to 0. X can be 0, but y is not a 0. So root 5 can be represented as x by y. Okay. So since root 5 equals to x by y, so we can write x equals to, this similarizes x equals to root 5 into y. So we took y in the left hand side. So I can write x equals to root 5 into y. Okay. Now let's do square both sides. Let's square both sides. So if you will square both sides, what will happen? X will be x square. Since I am squaring, so x will be x square equals to root 5 into y whole square. So this similarizes x square equals to 5y square. Okay. So x square can be written as 5y square. Okay. Now let's move on. So here we can see that x square, since x square is written as 5 into y square, correct? So x square is written as 5y square is nothing but 5 into y square. So this tells me that x square, since x square is a multiple of 5, that means it can be 10, 20, 30, like that. That is multiple of 5. So in other way we can say that x square is divisible by 5. Yes or no? Divisible by 5. Why I am telling you that? Because x square is a multiple of 5. That means it is only in the 5 multiples it will come. Correct? So whatever value, it can be like 10, 15, 20. So if you will see, we can say that x square is divisible by 5. Clear, right? Okay. So if x square is divisible by 5, so of course you see this, if x square is divisible by 5, that similarize, that says that x is also divisible by 5. By 5. Why? You want to know why? Let's do this. Let's take example. So if suppose x square should be a multiple of 5, right? So that means it can be like 15, it can be like 25. Of course, 15 is not a square form. So if x square is divisible by 5, and also it should be square form. So 15 will be not a correct thing. So it can be like 25. So it can be like 25. Then it can be 45. Because x square is divisible, so 45 by 5 is 9. Okay. No, this 45, it should be in the square form. So 45 is also not a correct example. We can take then 625 and we can take then 625. Then 5 into 5 into 5 whole cube. So it can be, so this is possible, x square is divisible by 5 only when x is a power of 5. Okay? Clear? So if x square is divisible by 5, then it should be in the power form, square form. So that's why I took it as x square as 25, x square as 25 whole square. That means 5 should be there and it should be in the square form. Correct? X square should be, because x is also an integer, okay, and it's divisible by 5, hence it can be 25, then 5 square, then 5 into 5 square, or 5 into 5 into 5 square. Correct? Similarly, n number of times 5 getting multiplied. N number of time you multiply 5 and there is square. So x square can be represented as like this. So you can see this, if x square 5 square, then x is 5. That means x is also divisible by 5. Clear, right? So x is integer and x is integer and x square is divisible by 5. So of course it can be represented as a form of 5 square, 5 into 5 square, 5 into 5 into 5 square, or 5 into 5 into 5 into 5. So n number of 5 you multiply and there is square form. So if you will see in these examples, so in this case x will be equal to 5. In this case x will be equal to 5 into 5. So like that it is. So you can see this. If x square is divisible by 5, then x is also divisible by 5. Okay. Now if x is divisible by 5, then I can write it as x equals to 5 into multiplied by some number k, where k is also an integer. Okay, where k is also an integer. So x can be represented as 5 into some number multiplication. Then only it will be divisible by 5. Okay. Now if x equals to 5k, then x square will be 5k whole square. That means 25k square. Okay. But what we have here, if you will see equation 1, x square is 5y square, and in second equation we have x square equals to 25k square. So if you are equating both, equation 1 and 2. So we have x square 5y square and we have x square equals to 25k square. So I can write it as 5y square equals to 25k square. Correct? So we can write y square equals to 25k square divided by 5. That means y square is also 5 into some integer square. So as we have seen over here, if x square is divisible, so here with y square equals to 5 into multiply by 6. So this proves that y square is divisible by 5. Correct? Since y square is multiple of 5 into k square, so y square is also divisible by 5. Now as I have seen, if x square is divisible by 5, so x was divisible by 5. Similarly, if y square is divisible by 5, that means y is also divisible by 5. Now, can you see the contradiction? We have both x and y, is divisible by 5. Clear? So we can say x and y is not co-prime. Why it's not co-prime? Because they have a common factor of 5. And what is co-prime? Co-prime number are pair of numbers which have common factor of 1 only. Other than that, there is no common factor. But here we are seeing that x and y is both divisible by 5. So they are not co-prime. Correct? So this contradicts our initial assumption that it can be represented in the form of two co-prime integers. So we have assumed x and y as co-prime, but we got x and y is not co-prime. So this contradicts, correct? So as per contradiction, since it contradicts each other, so as per contradiction, since we have contradiction, correct, we can say root 5 is irrational. Means our assumption was wrong. Root 5 is irrational and our assumption was wrong, correct? We assumed root 5 as rational, which is not true because it contradicts. Initially we have taken that x and y is co-prime, that is there is no common factor, but in the end what we got is x and y is divisible by 5. I mean both are divisible, that means they are co-prime. I mean, they is not co-prime. They are not co-prime. X and y are not co-prime. X and y are not co-prime. Correct? So it contradicts. So the moment we have seen contradiction, we can say that our assumption was wrong. And since our assumption was wrong, hence root 5 is an irrational. Hence proved. I hope you understood it. Okay, let's move to our second problem. What is the second problem? Prove that 3 plus 2 root 5 is irrational. Okay, so this we need to prove. Okay, so let's assume contrary. So let us assume on the contrary, on the contrary, 3 plus 2 root 5 is rational. Okay, so we have assumed as a contrary that 3 plus 2 root 5 is rational. So we can find two integers x and y where y not equals to 0 such that 3 plus 2 root 5 equals to x by y. Okay, so similarize it. Let's take this 3 is rational, we know that. So let's move on in our right side. So we can write 2 root 5 equals to x by y minus 3. So this whole thing is a rational because x by y, if you are subtracting a number from a rational number, the result what you get is also a rational number. Now root 5 equals to half into, so we took 2. Since 2 is multiplied over there, when you are taking it into the right side, it will be divided. So multiplication of left becomes division of the second side. Similarly, plus of the left side will become minus. So you can see over here, it was plus over here, so it becomes minus over here. Similarly, this is multiplied over here, so this becomes division in the right hand side. So root 5 equals to half into x by y minus 3. If nothing is there, that means into. So half into x by y minus 3. Now this was rational because I told you if something you are adding, subtracting, it will be rational. Now this whole thing is rational. Also, if you are multiplying or dividing a number or a rational number, if you are multiplying or dividing, then the output what you get, that will be also a rational number. So this whole thing is a rational number. So right hand side is rational. This proves that why RHS is rational. Why? Because A and B, because X and Y are integers and if you add, subtract, multiply or divide, the output, the result will also be rational. As simple as that. So RHS is irrational. Why? Because X and Y are integer, and if you add, subtract and multiply, divide, then also the result will also be a rational. So right hand side will be rational. So this proves that root 5 is rational. Because RHS is rational, so the left hand side will be also rational. Correct? So here we contradict. As we know, root 5 is irrational. Hence, our assumption was wrong. And and 3 plus 2 root 5 is irrational. I hope you understood it. So what I did, we have got, because X and Y are integers, and I told you, and X by Y is rational. So X by Y minus 3 is rational, because anything if you add, subtract or multiply, divide, it's be a rational number. So this thing is rational. So again, if you are dividing by, we are dividing by 2, that means 1 by 2 into X by Y. So we are multiplying a rational with a rational, because 1 by 2 is rational and X by Y minus 3 is rational. So multiplication of rational and rational, whatever the result you will get, that will also be rational. So this proves that root 5 is rational. Since this whole thing is rational, so root 5 is also rational, which contradicts our assumption, because we know that root 5 is a irrational number. So we can say that 3 plus 2, our assumption was wrong. Whatever initially we assumed, that let's assume 3 plus root 5 is rational, and we have represented it as a form of 3 plus 2 root 5 equals to X by Y, this line. So this is not correct. So 3 plus 2 root 5 is irrational, hence proved. Okay, let's move on and do our third problem. In the third, the first question is 1 by root 2. Okay, again all the problems we are going to do with the normal contradiction method only. Okay, So let us assume 1 by root 2 is rational. So again we can find two integers x comma y, where y not equals to 0, okay, such that one by root 2 equals to x by y. Okay, so we have assumed 1 by root 2 is rational, and since it is rational, it can be represented in the form of p by q. Okay, some ratio for here x by y. Okay, so we have assumed 1 by root 2 is x by y. Now let's invert it. What does it mean? So we will make denominator as numerator, or divide it by 1. Divide LHS and RHS by 1. Or you can say that just invert numerator and denominator. Both sides. If you are doing some operation, if you are doing on the left hand side, you must have to do on the right hand side also. What I am doing is, either you can say invert numerator denominator, or divide LHS and RHS by 1. I mean 1 divided by LHS, 1 divided by RHS, the same thing. So we can write it as root 2 equals to y by x. Why root 2? Root 2 by 1, right? So I converted numerator to denominator and denominator to numerator. So root 2 by 1 equals to y by x. Now root 2 by anything divided by 1 is that number only. So root 2 equals to y by x. Okay. Now you can see over here that root 2 becomes y by x. Okay. Now y by x is a rational number. Correct? Y by x is rational. Correct? As y and x are integers. Hence y by x is rational. Therefore root 2 is also rational. So is root 2 rational? No, it's irrational. It's inside a root. So it contradicts our assumption. It contradicts okay, because this statement contradicts, because root 2 is rational, we know that. It contradicts, as root 2 is irrational. Hence so since we got it contradiction, we know that root 2 is irrational, but what we got is root 2 is rational from our assumption. So we can say our assumption that 1 by root 2 is rational is wrong. So this we have assumed initially that 1 by root 2 is rational. That is wrong. That is 1 by root 2 is irrational. Proved. So you assume something and you contradict add the end and then say our assumption is wrong and what we assumed was wrong. Okay, assumption that 1 by root 2 is rational is wrong, hence 1 by root 2 is irrational. Okay, next, second one is 7 root 5. We have to tell that we have to prove that 7 by root 5 is irrational. Okay, so again let 7 by root, so we assume, so let us assume where we are assuming it. Of course it is going to contradict. So let us assume that 7 root 5 is rational. So therefore we can find two integers x and y such that, and of course y not equals to 0, such that 7 root 5 equals to x by y. Okay, so we assume that 7 root 5 is rational. So of course if it is rational, we can of course convert it to the form of a ratio, there p by q form, you remember. So we have converted it to, so there must be two integers x and y. If it is rational, there must be two integers x and y where y not equals to 0, such that 7 root 5 is represented as x by y. Okay, so this similarizes root 5 equals to x by 7y. Okay, now since x by y is rational, and so therefore x by 7y will also be rational, because y is integer, so 7y is also integer, right? So since y is integer, so 7y is also integer, so x by 7y is a rational number, correct? So x by 7y is rational. Why? Because x and y are integers, correct? X by 7y, I told you, right? If you are multiplying something, so x, see, top one is integer. If y is integer, so 7y will also be integer. So x by 7y is a rational, integer by integer. And of course, the bottom one, if y is not 0, 7y is also not 0. Correct? So x by 7y will be rational. Okay. Now, if x by 7y is rational, then of course, this proves that root 5 is rational. So here we contradict. Okay. So this contradicts the fact that root 5 is irrational. So it contradicts the fact that root 5 is irrational. Okay, so we can say our assumption that 7 root 5 is rational is wrong. So whatever we assume in the beginning, that is wrong. Hence 7 root 5 is irrational. Okay. proved. I hope you got the problem. Okay, let's move on to our third problem. So what is the third problem? It's 6 plus root 2. Okay, so to prove 6 plus 2 is irrational, let us assume, let us assume 6 plus root 2 is rational. So if it is rational, then of course, therefore, we can find two integers. We can find two integers x and y, where y not equals to 0, okay, such that 6 plus root 2 equals to x by y. Clear? So this summarizes root 2 equals to x by y minus 6. Correct? Now, as I have told you already, if you are adding, subtracting, multiplying, division by any number, any integer, then the result will be a rational number. We know that. So since x and y are integers, therefore x by y minus 6 is rational. I told you. Okay? Because we know the basic fact that if you are adding, multiplying, subtracting or division by any number in a rational number, then the result is also a rational number. So here we are saying that, of course, in a rational number becomes by the integer division only, the ratio of two integers. So we know that x and y are integers, and we are adding some number in the integers. I mean integer by integer minus we are doing 6. So the result is also rational. So what it say? If the right hand side is rational, so the left hand side will be also rational. So root 2, this proves that root 2 is rational. Now this contradicts. So this contradicts the fact that root 2 is irrational. Correct? Because we know anything inside the root is irrational. But what we have got is root 2 is rational. So this contradicts our normal thing. I mean, which we know. The fact we know is root 2 is irrational. But what we got is root 2 is rational. Hence we contradict. Okay? So therefore, we can say our assumption was wrong. That means 6 plus root 2 is irrational, because we assume 6 plus root 2 is rational, which is wrong. We proved it already. Hence 6 plus root 2 is irrational. Hence proved. So I hope you got the problem. Okay? If you like my video, please don't forget to like and subscribe. Okay? So I'll see you in my next lecture, which will be exercise 1.4 of the real number. Till then, thank you and bye.